Today we're going to continue our study of functions. Last time we talked about how we can evaluate functions, how we can tell whether or not an equation is a function, and we also talked about the difference quotient. So today we're going to talk about the domain of a function. So when we talk about the domain, we are talking about the set of all possible x values. Now there are two special cases that we need to look for. First, if you have a denominator, you want to set the denominator equal to 0 and solve. So the reason is because if you have a value in the denominator and that x value creates a 0 in the denominator, then you don't have a y value. Your y value is undefined there. So in order to find those values, you take the denominator, set it equal to 0 and solve, and x cannot equal that number. The second case you want to look for are square roots. So for square roots, you know that you cannot have a negative inside of the square root. So we are going to take what's inside the square root, we're going to set it to be greater than or equal to 0 and solve, and that will tell you what x can be. And we'll take a look at some examples of how we can use these and how we can look for these two particular cases. Alright, so looking at this example, we have x squared minus 6x all over x minus 1. So anytime you see a fraction, right away, you take that denominator and you set it equal to 0. So in this case, x minus 1 equals 0. Solve it, so x equals 1. So we know that when x equals 1, your y value is undefined. So we can say that the domain of the function is going to be all real numbers except 1. Let's look at the next example. F of x equals the square root of x plus 2. Now we see a square root, so right away we want to take what's inside of the square root and we want to set it to be greater than or equal to 0, right? What's under the square root has to be either positive or equal to 0. Solve that, and we get x is greater than or equal to negative 2. So you know that anything that's less than negative 2 will make the y value a non-real number. So remember, for the square root, when you set this to be greater than or equal to 0, this is telling you what x can be. So as long as x is greater than, or could even be equal to, negative 2, then your value of x will give a value of y. So for the domain, you would say x is greater than or equal to negative 2. All right, the last place where we're going to talk about the domain is when you're given a piecewise function. So here's an example of a piecewise function. So the first piece, the 2x plus 3, is true when x is less than 4. And then the second piece is x squared minus 1, which is true when x is between 4 and 10. And now we want to state what the domain is. Well, before we get there, let's just say how we evaluate these functions. So just like you would evaluate any other function, you would first look at your x value and you would plug it in. The one thing is you have to figure out which piece it plugs into. So that's where the second portion, the x less than 4 and the x between 4 and 10 inclusive, comes in. So for example, if you're asked to find f of negative 5, well, negative 5, do I plug that into the first one or do I plug that into the second one? You should not be plugging it into both. If you're plugging it into both, you may end up with two different y values, and you know that each x value should only have one y value if this is a piecewise function. So let's determine which piece of the function this belongs to. Well, negative 5 is less than 4, so that tells me that this belongs with the first piece. So I'm going to plug the negative 5 into the 2x plus 3. So 2 times negative 5 plus 3. That's going to be negative 10 plus 3, which is equal to negative 7. Now what about f of 8? Well, again, check. Your value of x is 8. Does that belong in the first piece? Is it less than 4? No. Is it between 4 and 10? Yes. So I'm going to plug the value of 8 in for x in the second piece. So this is going to be 8 squared minus 1, which is 64 minus 1, which is equal to 63. What about this one? F of 15. What does that equal to? Well, again, do the same thing. Is 15 less than 4? No. Is 15 between 4 and 10? No. Now, if it doesn't fit in either of those pieces, then you can say it's undefined. Now that brings us to the last part, which is what is the domain of this function then? If 15 is not in the domain, what values of x are defined for this function? Well, x can be anything that's less than 4. X can also be anything between 4 and 10. Can it be 11? No. Can it be 10.1? No. So your domain is anything from negative infinity all the way up to 10, including 10. So for the domain here, you just want to make sure that you are including all values of x that you can plug in. Now, you want to make sure that you're not thinking, oh, as long as it's not 11, it's fine. You want to think of it as, well, it will only go up to 10. 10 is the highest number it can be. You want to include 10 because it can be less than or equal to 10. So that's why you have the square brackets there.